All right, we're here at the shop at Badass Racing Engines. This whole show is on nitrous oxide. It's also called juice, squeeze, spray, throttle in a bottle. Some people even call it NOS, although NOS is really the abbreviation for the brand name Nitrous Oxide Systems, NOS, so it kind of got called NOS there for a while. And that's okay, but that's not the chemical makeup of the formula of nitrous oxide. The chemical makeup's N2O. It's nitrogen 2 parts to 1 part oxygen, hence the N2O. But NOS, some people call it that, but that's just the abbreviation for nitrous oxide systems, which is basically a brand name. Nitrous is laughing gas. It is the same stuff when you go to the dentist. It's the same stuff they give you to kill pain and when you're getting your teeth worked on. Well, another thing that's not nitrous is NOx, N-O-X. NOx is basically a form of pollution that happens when the gases in a combustion chamber or a cylinder reach 2,500 degrees or more. It creates nitrogen oxide, which is basically smog. So some people call nitrous NOx. It's not NOx, it's N2O or nitrous or whatever you want to call it. NOS, squeeze, spray, juice, all that fun stuff. Nitrous has been around since a long time. I mean, it was discovered in the late 1700s. It was first used in an internal combustion engine in World War II fighter planes. I mean, they're flying up at 30, 40,000 feet. There's no oxygen up there. So some of the Allied forces need something to get their planes a little faster and a little gain on some of the enemy planes. So what they did was they introduced nitrous oxide into the engines, and it gave them that extra shot of power. Basically what nitrous is, it's just a higher content of oxygen. Again, it's 2 parts nitrogen to 1 part oxygen. So basically, it has between 15 and 20% more oxygen content than our normal atmosphere. And basically, you know, nitrous doesn't burn. It's non-flammable. I could take a match, turn this thing on, and blow the match out with it. It just oxidizes the fuel that's being burned. So in nitrous oxide, the power comes from the fuel, not from the nitrous. So let's talk about that a little bit. You know, I just said nitrous adds oxygen and the power comes from the fuel, not from the nitrous. Well, horsepower, the whole key to horsepower is raising cylinder pressure. I mean, it's a no-brainer. You got a combustion chamber and you got a piston and a rod going up and down, and it's turning that crankshaft. The bigger the bang inside the combustion chamber and the cylinder, the harder it's going to push that crank around. Horsepower is a no-brainer. Raise cylinder pressure, make power. The only way you can raise cylinder pressure, though, is to either have higher flowing heads and bigger camshafts to allow more flow of naturally aspirated engines to go inside there. If you just put a lot of fuel in there, you need the air to burn with it. Well, you don't have the air, you don't have the oxygen content, so all you do is flood the motor out and it gets a poor burn and you really lose horsepower. What nitrous does, though, is add the oxygen, and the oxygen is needed to burn more fuel. So consider this, you know, you got a small carburetor on a regular engine and it's only allowing so much fuel and air to go in there. Well, you got like a little firecracker going off in there. It's making power, get you down the road. How about having an M80 in there, though? Boom, boom, bigger power, turns that crank around harder. Well, it's nice to take that little M80 and turn it into a stick of dynamite. That's where the power comes from. Well, the carburetor and the size of the motor can only draw in so much fuel and air, and it's only capable of burning so much fuel and air. When you add a nitrous system, it adds more fuel and an oxidizer inside to help burn that. That's where the power comes from. You're able to burn more fuel. You got a big explosion going off in there. It pushes that crank around, more horsepower, and it's all at the push of a button, instant horsepower. We talked about nitrous being N2O, which is basically 2 parts nitrogen, 1 part oxygen. That's about 35% or so oxygen content by volume. And basically we said it allows you to burn more fuel by adding oxygen content. Let me kind of give you a visual on that. I'm sure some of you are familiar with this. Here's your typical cutting torch right here. This is the fuel. It's burning the oxygen in the air just naturally. If we add oxygen to it, we're going to get a really hot blue flame. As the more oxygen we add, the bluer the flame gets until we get to a really nice clean burn. Right there is a perfect air-fuel ratio of the amount of acetylene going in and the amount of oxygen. Okay, if we want to make even more power and make the flame even hotter, add more fuel. Well, if we do that, it's going to cool it down. Here's more fuel. You can see the little blue inside there got a little longer. So we're going to add a little more oxygen to it and make even better burn. There we go. Now here's a problem with adding too much oxygen. This is a cutting torch. If we had this against a piece of steel and we started doing this, we're going to start cutting holes in the steel. That's how you cut steel and cut brackets off of frames and stuff. So we have to be careful about the amount of oxygen that we add to amount of fuel. We got to keep it within reason or stuff starts to happen. And what I mean by stuff starts to happen is if the components inside the engine, pistons, spark plugs, cylinders, gaskets, things like that, if they're not up to a certain amount of par for that amount of heat and pressure, you're going to start having troubles and melting things down. This also accounts for ring gaps, piston skirt clearances, and things like that, which we're going to get into a little bit later, how to set an engine up for nitrous. But as long as you keep it fuel friendly and keep the air-fuel ratio in a given area, the parameters and everything, it's a pretty safe power adder to use. We talked about earlier about nitrous oxide being indeed the same stuff, laughing gas, that you get at a dentist's office. I want to really stress this though, and I can't stress it enough. Do not go breathing this stuff. Don't be getting at a party and going, hey man, I got some nitrous oxide, let's all get high. You're going to kill yourself or kill somebody else. There's medicinal grade and there's automotive grade nitrous oxides. Basically, chemically, they're both exactly the same. Automotive grade, though, they add a little bit of sulfur dioxide to it, which makes it basically stinky. It smells like a bunch of old farts, okay, or rotten eggs. That's just to help keep you from breathing it. But even without that, if you got some, one thing, there's several things about this. One is nitrous oxide is freezing cold. So if you go cracking the valve open, you go to breathe it, you're going to freeze your lungs. It's like liquid nitrogen, liquid oxygen. I mean, it's way below zero. You're going to get frostbite. That's bad enough in itself. Second thing is it displaces oxygen. I mean, this is basically like a drug. I mean, they use it in the medical field as an anesthesia. You will end up passing out and dying. I mean, let me give you an example of this. As a young kid, we used to go up to a particular place in East Bay in the hills just at night to hang out with the guys, and we'd have all our cars up there and stuff. Well, some idiot swiped a bottle from a dentist's office, and they were up there filling balloons up and getting high off it. Well, one of the kids died that night. He had too much. Next thing we know, there's an ambulance coming up, and they carted the kid off with a blanket over his face. He died of it. Not a smart thing to do. There's plenty of other things you can get mischief in out there. You don't need to be doing this kind of stuff for that. It's just too risky, so don't do that. Second thing with nitrous, all in all, nitrous is very safe. And by far, it's the best power adder, best bang for the buck power adder you can possibly purchase or put on your car. So you're probably asking, Aaron, if nitrous is so great, where did it get its bad reputation from? Well, it's pretty simple. You know, a guy will go out, especially a youngster, will go out and buy nitrous for his car, and of course he's got a hand-me-down car that's probably got 110, 120,000 miles on it, and it's cheap. You buy, a $400 kit, bolt it on, and go, hey man, we got this new kit, and you push the button and instant 100 horsepower. And a stock motor, a stock V8, American-made V8, will handle 100 horsepower. Of course, an import won't. It's a little too much for it, but 40 or 50 on an import motor would certainly be fine. So you got this 100 horsepower gain, you're going down a freeway going, yeah, this feels good. Let's try the 150 horsepower shot. Well, it's going to work. I mean, it's going to feel good and you're going to go faster. Next thing they do, let's try the 200 horsepower. And guess what? A factory motor can't take those kind of pressures. Even if you didn't have nitrous oxide on that kind of a factory motor and you just say put a good set of heads and a big cam and raise the compression, the lower end components are not designed for that. You're going to eat that motor up. And a lot of people say, oh, nitrous oxide, it melted my motor down. That's a bunch of BS, okay? Unless you put this huge shot on there or you lean the motor out, nothing like that's really going to happen. You have to have it in moderation. I mean, just as with anything, you certainly couldn't go buy a big supercharger and put it on a stock motor and pump the boost up to 15 pounds of boost. You'd blow the crank out the bottom of the motor. But 4 or 5 pounds of boost on a stock motor, it'll go all day. Everything's in moderation. Well, the same thing with nitrous oxide. A 10-pound bottle here, that gives you, probably 20 to 30 seconds of the button being pushed, of fun, basically. Well, you certainly can't go down a freeway with a button pushed or with the engine floored blasting down a freeway for 20 or 30 seconds at a time. The stock motor can't take that kind of pressures and loads that are going on that. But for short bursts and high gears only, and you can only use nitrous oxide under full throttle, and you only want to use it in high gears because, man, an instant shot of 100 horsepower, you're throwing in a seed. I mean, it's like adding another V8 under the hood. So nitrous really got its bad reputation from people that just didn't consider the thoughts of moderation and, gee, what will this old V8 motor, even a new V8 motor, but especially an older one that's the rings are on their way out, it's got stock pistons in it, stock bearings, stock clearances. When you're adding fuel in there and oxygen, you're going to add heat. Heat expands metal. It has to have a place to go. And later on when we talk about internal engine components, we're going to talk about how to set a motor up for that. But on a factory motor, if you keep it moderate, 75 to 100 horsepower on an American V8, you're fine. 40, maybe 50 horsepower shot on an import motor, you're fine. And that's a real good feeling. But the urge is to add more because it goes better. Well, the stock motor can't take that. So it really got its bad reputation kind of in a false way. And it's just, it's not fair on the nitrous, because nitrous is very safe, it's very cost effective, it's a lot of fun. Trust me, it's a kick in the pants to hit the button and all of a sudden feel this big horsepower shot. I mean, it's like someone in the back seat kicking the back of your seat. And all of a sudden, wham, you feel it, and it feels awesome. So the urge is to add more. Wow, that felt good, let's add more. Stock motors can't keep taking more and more and more before they finally let loose. So you just have to use it in moderation. You go with a manufacturer's specs. They'll tell you, start off with the smallest jets that come with a kit. Most kits are adjustable, 50, 75, 100, 150 horsepower. Import kits come, like 25, 45, 65, and 80 horsepower shots, stuff like that. Well, you don't get a kit and immediately put the biggest shot on there. You're going to have trouble. Besides, if you're running a little bit lean or a little rich, you can have tuning troubles. And trust me, you never want to lean a motor out when it's on nitrous, because just like that cutting torch you saw, when I added the oxygen to it and you saw that, the flame got hotter. Happens inside the cylinders too. You add more fuel and then add more oxygen, you're going to increase the BTUs, the heat inside the cylinders. Add more oxygen and lean it out. Oh man, it's just like when I leaned that torch out and you saw the blue flame come back down and hot, and then I added more oxygen to it. You can cut steel with it. It's no different inside the motor. You're going to melt pistons down and stuff. So moderation and properly tuned is very, very important. But once those steps are taken, a nitrous motor lasts for a long time. I mean, a really long time. I've seen stock motors with 75 and 100 horse shots out here at the racetrack running year after year after year on stock motors, never have a problem. But you just can't be stupid about it. You can't take that stock motor again and put a 200 horse shot on it, because that pass you just make right there, it's probably your last. So let's talk about the pros and cons of nitrous. Let's start with the cons. The only downside to nitrous really is you got to refill the bottles, and it's no fun when your bottle's empty. One of the downsides also is that you can't drive around with the bottles on. You got electric solenoids up at the motor, and they hold the nitrous back until you push the button. But sometimes they leak a little bit. I mean, you got quite a bit of pressure in here. There's 950 to 1,000 pounds, ideally, of pressure inside one of these bottles going to the solenoid. That's a lot for a little electric solenoid to hold back. So if you leave the bottle on, what can happen is, normal driving conditions, you'll never notice it. But say you stop, you pull over and go into a store to go get yourself a sandwich and a soda or something like that, and you're in there for 15 or 20 minutes. When you come back out, the solenoids could have leaked a little bit just from the pressure, and you go to start the engine up. Sometimes when you start an engine, they'll do what you call a lean pop. And when you pop with all the nitrous inside the intake manifold, and when you go to add fuel, you give it the pump of gas, turn the key, and it spits, it'll blow the manifold right off the motor, blow the carburetor off right through the hood. I've seen catastrophes like that. So that's one of the cons also. You can't leave the bottle on. So you got to drive around with the bottle off until you're ready to use it. That's kind of a downside, but if you know you're going to use it, you can turn the bottle on. There's also, which we'll see a little bit later when we talk about bottles, electric solenoids and electric bottle openers. So that kind of solves that con. Another one is, they're a little touchy on air-fuel ratios, but once you get that set in tuning, adjusting the jet size and stuff like that, which the manufacturers give you guidelines to go by, and if you follow the guidelines, that's pretty simple. Another one would be, let's see, smoking a little bit. Sometimes cars smoke a little bit and use a little bit of oil when they're set up for nitrous. I'm not talking about a stock engine. I'm talking about a higher horsepower motor. If someone came to me and says, hey, Aaron, build me a nitrous-ready motor. Well, we talked about it before. Nitrous adds fuel and oxygen in there to make a bigger bang. Well, that creates heat. We saw that on the torch, the oxyacetylene torch, the heat that it creates. Well, heat expands metal. It's got to have a place to go. So on a nitrous motor, you got to open up ring gaps and piston skirt clearances and things like that. Well, that's designed to be run when it's on the nitrous. When you're not on the nitrous and you're just putting around town or sitting in work traffic, you're not seeing those kind of temperatures. So the piston's not expanding where it should, and the rings aren't expanding where they should be. So you got wider gaps. Well, it's like having a worn out motor with wider gaps. What happens? They start smoking a little bit and they start using a little bit of oil. If you know it's going to be that way, who cares? The motor's set up for it. It's more friendly when you're on the juice than when you're off the juice. So that's okay too. So what I'm getting at, the cons really aren't that bad. There's really no real downside of nitrous other than having to refill the bottles. And if you keep a spare bottle around or have twin bottles in the back, then that helps you even more. You got double the capacity. Let's look at the upsides of it. It's cheap. It's cheap horsepower. I mean, it's big bang for the buck. You can get a kit for, under $400 for a decent little kit. Of course, they go up from there. Some of these kits go up to $1,000 to $1,500 for 2- and 3-stage kits and stuff like that. Of course, you're getting a lot of goodies with it. Another thing is, what's great about these on the upside, they're easy to install. A couple of hours and you got it installed. Especially on import cars with a dry system, geez, you can have the thing installed in, oh God, 2 or 3 hours and you're driving down a road with nitrous oxide. It's really not that hard to put in. Next best thing about these, this is one of the few major power adders that's 50 state legal. Not all the kits, some of the kits, only the ones that say they are 50 state legal. Of course, you can't go get in a dual stage fogger system and say, well, it's 50 state legal. The reason they do that is because you're not on the nitrous most of the time. You're only on it for a short burst of time. And under most conditions, when it's a small shot, 50 horsepower, something like that, 60 horsepower, it's not really adding to the emissions coming out, not that much. So there are 50 state legal systems. Like I said, though, you can't obviously get a dual stage fogger system or a 250 horse plate system and have that pass smog. So that's up to your discretion. But there are 50 state legal kits, and that's hard to find in the power industry. I mean, a lot of aftermarket go fast goodies aren't smog legal. So that's kind of one of the cool things about nitrous is being able to have it and still be able to pass smog, because that can be a real pain in the butt sometimes. All right, let's talk about the different components of a typical nitrous system. Obviously, you have the bottle, and there's different size bottles. We'll go into those next, but you have the bottle. The next item that you always have are solenoids, and this is what controls and regulates the pressure going into the motor, both of the nitrous oxide and the fuel. And basically what this is, we talked about the pressure in the bottle before, was about ideally 950 to 1,000 pounds. Well, that's what these solenoids are holding back. This particular guy right here, they usually marked on them nitrous, and usually the red ones, almost always red, is fuel. And the nitrous solenoids can be blue or green or yellow or whatever, but an industry standard these days is red is always fuel, red for fire, and being that nitrous is cold, a lot of times you'll see blue fittings, and we'll show you that next here. You see blue or different colors for the nitrous. But on the nitrous solenoid, it's holding back all that pressure, and it's 950 to 1,000 pounds of pressure on the bottle that this little guy's holding back. And basically there's electric. You got a couple of wires right here. One's a power and one's a ground. And when you activate the system, it turns the solenoid on right here. And inside here, there are little, basically like a needle and seat that click open and click closed and allow the fuel or nitrous to flow through the solenoid. You always have an inlet, and they're clearly marked on the back, in, right there. And there's an out right here. So it clearly shows which way the fuel or nitrous is going to flow through the solenoids. Most wet systems, or all wet systems, and there are wet systems and dry systems, but all the wet systems run two solenoids because you need a solenoid for the nitrous and you need a solenoid for the fuel, and that's what controls the two of them. Now you notice here there's also smaller solenoids. These are the little guys right here. These are usually on economy kits. They're just a lesser expensive, sometimes a lesser grade. Not that they're a lesser grade material, they're just a little lesser grade duty cycle than what the large solenoids are. So in the more expensive kits, you'll find the larger solenoids. In the lesser expensive kits, you'll find the smaller solenoids. And they both do the same thing. They're exactly the same. Again, red is for fuel. And if you look, same thing. There's where it says out right here on the outside. And you flip it around, and here's where it says in. So it shows you the fuel or the nitrous direction of flow. They're real simple. And all of them have two wires, just a simple hot wire that comes from a switch and a ground. All right, speaking of switches, here's the switches right here. There's actually three types of switches that are used in nitrous. And no matter what kind of system you have, you always want two switches in line. Meaning you have an arm switch. This goes up on the dash. You want to mount this on a dash somewhere. So this, when you turn it on, that makes the system hot. Okay? That way when it's off, you can't accidentally activate it, okay? No matter what you do, if you have a nitrous switch, like say this one right here, mounted on your shift lever, and you reach down and push it, you don't accidentally turn it on unless the arm switch is on. So you need the arm switch to be on, and then a switch like this would be mounted on the shift lever, and you can turn it on, okay? And as long as you hold it on, the solenoids are open and it's flowing fuel and air, or fuel and nitrous. Okay, there are other switches also. There are micro switches that are on the throttle linkage, and those work when you're at wide open throttle, they'll kick on. Now some race rules are now saying that you cannot run these hand-operated switches or button switches on the shift lever. They want you to go ahead and use the ones on the throttle. Personally, my own personal thought on that, I really don't like that. And let me give you a reason here. You never use nitrous unless you're in higher gears and at wide open throttle. You never want to use nitrous in first gear, and sometimes even early in a second gear, especially shifting between first and second. One reason is you're adding an instant shot of power. I mean, it could be 100 horsepower, could be 200 horsepower, depends on what you're adding. Well, in low gears like that, it's easy to blow the tires off. I mean, just put them up in smoke. Well, if you got an engine that tacks up pretty fast, goes from say 3,000 to 7,000 RPM instantaneously, imagine adding nitrous to it. Now it tacks up even faster yet. So you have a really good chance of hurting the motor or over revving the motor when you're spinning tires or when you're in a low gear. So you really only want to use it at wide open throttle in higher gears. Okay, well the problem is when you run the switches that are on the carburetor, so when you're at wide open throttle, as long as you're at wide open throttle, you're on the bottle, on the juice. Okay, well the problem is if your system on the dash is armed and you have your arm switch on and you're in first gear, say taking off from the line, how are you going to control it? You're not sure where 3/4 throttle is or full throttle is on the gas pedal, so you really don't have good control of that. Well, you're doggone sure when you got the button pushed or not. So for safety-wise, in my book, it's a lot safer to use the button on your shift lever because you can go through first, shift, hit second, wait, bam, hit the button, there's your nitrous, and off you go. When you're on the throttle and you got the system armed, you don't know when you're using a micro switch on the carburetor or on your fuel injection and stuff. You don't know when it's going to kick in. You're trying to control it with your foot, and it's too hard. And worse yet, someone just say, well, Aaron, just disarm the system and just arm it when you want. You're trying to drive a car and shift and do everything else. You got better things to do than be reaching up on a dash trying to push a button while you're trying to grab the next gear. That's too hard. That's not safe. It's, the whole object of this is safe fun. That to me is not safe. You want to just arm it, you're done. You know the nitrous is going to kick on. Well, it's a lot more controllable with a push button switch on your shift lever. Some shift knobs themselves have buttons built into them. But some of the new race rules and sanctioned race rules, they're requiring you to run it on the throttle. And that might be okay at the track, except for the fact you're launching off the line. You don't want the nitrous when you launch off the line. God, you're going to spin your tires, and you're going to sit there smoking the tires and going nowhere. Your 60-foot time is going to be crap. You don't want it to come in until probably half track. Well, you can't control that. So I really don't like that ruling. It might be a safety thing, that's fine, but as far as practicality, I think it's down the dumps. That's just not happening. But they call the rules, so we'll let them do it. We'll go on to the next component here, are on plate systems. And there's two different types of nitrous systems. There's plate systems and there's direct port systems. So on a typical plate system, this is an Edelbrock plate system right here, and they're all good. There's Nitrous Supply, there's Nitrous Works, there's a Nitrous Express, obviously NOS, Nitrous Oxide systems, Edelbrock. They're all real good. They're all top of the line stuff. This is a typical plate system right here. And basically it consists, you've got two what they call spray bars in here. And if you look real close, you can probably see there's little teeny tiny holes that run right along here. You can just see those. Okay, well each spray bar right here is in line like this one right here. If this is the fuel bar, then it's in line with the red fittings. And here we are again. There's your red fittings. And that tells you that the fuel bar is aligned with the fuel line. And then obviously here's the nitrous one right here. And again, nitrous is blue because it's kind of cold. And there's your blue. Okay, and that would go into the nitrous. So when you hit the button, out of one rail right here sprays fuel, and out of the other one simultaneously sprays nitrous oxide. So you get this continual spray, fuel and nitrous going into the motor. Well, the way we control the amount of that is by the jets, and there are jets hidden in here inside these fittings, and I'll show you. We'll take one out, just undo the line, we'll pull that off, and right here is a jet. And these are adjustable. You just simply pull them out. They can only go in one way. The way they're designed, you can't put them in backwards. They will not go in backwards. You can only put them in one way. So you can put that in. And by the size of the hole in here, just like a jet on a carburetor, that's how much fuel or how much nitrous is being controlled to go through the spray bar. Obviously, if you go to a larger hole, you're going to increase power. If you're going to go to a smaller hole, it'll decrease power because you're decreasing the amount of fuel and nitrous going in the motor. It's a really simple setup. Okay, so obviously there's the jet. Well, there's the same jet for the fuel. You can take the fuel line off. And what these lines do, they go around to the solenoid. They'll bend around and go right to the solenoid. And here's another jet right here. Okay, now always follow the manufacturer's rules or specs on what jet size to start with. And again, moderation. Don't go buying a kit that's adjustable from 50 to 150 horsepower and starting off with 150 power level. Start off with the 50, get used to it, see how it works and runs, because you want to work your way up. If there's a problem, trust me, less catastrophe is going to happen at 50 horsepower than at 150, okay? That's a lot of cylinder pressure going on in the motor when you're on the big power levels, okay? And you don't want to have a catastrophe happen at the higher power level. So just by controlling the jet sizes there, it controls the amount of fuel and nitrous going in the motor. This is your typical spray bar plate system. Then we come back over here. This is a brand new system from Zex, okay, Zex Nitrous Systems. Basically what it is, instead of the spray bar being in the way, creating a little bit of a blockage, a little bit of a airfoil in the way there, what this does, it goes all the way around a perimeter. If you look in there, you can see all the way around are holes. You see that right in there. Well, what this does right here is you got clearly marked nitrous on this side, fuel on this side. So you put your jets in, you have your lines that would hook up, and instead of spraying through a spray bar, it comes around the whole perimeter of this plate and sprays evenly right on inside. Well, you always have to keep in mind on these too, if you notice it says up, okay? Same with the regular plates. They'll have fuel marked on one side clearly, they'll have nitrous, and then look over here, up. You do not want the spray bar to be upside down. You don't want to mount it like this because the carburetor sitting up here, it's going to spray everything up into the carburetor. You're going to have this terrible turbulence in there. So a simple quick look, make sure they're facing the right way when you mount these down. But the perimeter plate's kind of cool because it sprays all the way around an even flow of fuel and nitrous in a more even area, and especially like an open plenum manifold. This is a hot little setup. It's a neat little design. All right, so let's go on to another type of system. We just talked about plate systems. Let's talk about a nozzle system, or what we call a direct port injected nitrous system. And here's one right here. This is a fogger nozzle. And again, you know, they're marked clearly by the fittings on here. It says right here nitrous and fuel, and of course the nitrous has the blue fitting on it, and the fuel side has the red fitting. Of course, you can take these on or off and mix match them if you wanted, but you don't want to do that. Always keep the blue for the nitrous and the red for the fuel, and it makes it simpler for as far as plumbing goes, and as far as seeing where a problem is, or if you got a line that's leaking, you know which one it is. But basically what this does, if you look real close here, both of these fuel and nitrous gather together inside here, and they both come out right here in a fog pattern. When it sprays, instead of it spraying across the spray bar, it comes out in a highly mystified fog. That's why they call it a fogger nozzle. And this is a wet system, so you have fuel and nitrous being blended together inside. And there'll be 8 of these on an 8-cylinder. So on an intake manifold, you'll see one in each runner, and it sprays directly down towards the valve. Now these are directional, obviously, because it sprays here, and it does not spray on the backside. So they're directional, so when they go in the engine, you want the air-fuel mixture to be coming down this way and have it spray towards the intake valve, towards the combustion chamber. You certainly don't want it spraying right back up in towards the carburetor or anything, so they are directional. There are places that install these systems, Nitrous Supply probably being one of the better choices. If you're not sure about plumbing this kind of stuff, you can always give them a call and they'll be glad to do it for you. This is usually big boy stuff. This is usually 250 horsepower to 600 horsepower systems on fogger systems like that. So it's not something you're probably going to be running around on the street with. All right, now let's talk about a dry system. This is a dry nozzle right here. It looks real similar to a regular fogger, only if you notice there's only one line going to it. This is for like late model cars. Dry systems means there's no fuel. It's just nitrous. And what happens is the reason you would have a dry system on, say, a fuel injected car, like a computer controlled car basically, imports, American made, anything like that, is your computer system's all on the fly. I mean, you have an O2 sensor in the exhaust, and it's constantly taking readings of how much fuel and air is coming into the motor, and it adjusts on the fly. Well, when you just introduce nitrous, the O2 sensor says, oh, higher oxygen content. Okay, here's more fuel. So it adjusts for you. Where a wet system, it doesn't. You look at a wet nozzle right here, okay, and you have both of them. You have fuel and nitrous. And of course inside, we can take this apart. Just like the plate systems, guess what's inside here? Jets, okay? And of course, same thing with the fuel. You take it off, and here's the fuel side. And there's a fuel jet, all right? So really, when you look at a fogger nozzle, there's really not that much to it. It's just a little nozzle, and both of them come together and spray out here. Well, the dry system is basically the same thing, only no fuel going inside of it. The engine will adjust for that with a fuel injection system. These are really simple to install. Imports, man, you can have one of these on in 2 or 3 hours, and you're down the road. Where a wet system on a earlier V8, like a muscle car or something like that, you got to plumb in fuel lines and tap into the fuel pump. Sometimes you might want to run a spare fuel pump. You got, all kinds of little goodies to mount and wire in. Where on a dry system, man, are pretty simple. You pretty much plug them in and go, and put this in the air inlet, the air intake inlet, and off you go. So these are real slick little systems. And of course, just for adjusting the same power on your import car or late model like a Chevrolet or Ford, anything like that, same thing, there's a jet right inside there. And just by adjusting this, just one jet size right here, you adjust the power. Obviously, you can only go up on an import car. You can only go up so high. And same thing with an American car, a late model computer-controlled American car. You can only go so big on the jet. You can't, if the kit that comes with it that's recommended for your car goes up to, say, 80 horsepower, okay, you certainly wouldn't want to put jets big enough to go to 150. The reason being is your factory computer and fuel injectors are only capable of going to a certain extent before they peter out. I mean, they can only flow so much fuel. That's when you got to get bigger fuel pumps. You can control the fuel pressure regulator as to how much goes back to the fuel tank. You can adjust for higher pressure injectors, going from a 18 or 24 pound injector on up to 36 pound or 42 pound injectors. You need to adjust all that kind of stuff. But on a normal system that comes with the recommended jet sizes and it's recommended for your car, you stay within those parameters. And again, we're coming back to that word moderation. Okay, you stay within the moderation area of what the engine's capable of handling and what the kit is designed to do. You won't have any troubles. It's only when you start goofing around going, hey man, 80 horsepower felt great. Let's put my buddy's 100 horsepower jets in there and see what happens. And you know what's going to happen. You're going to eat the motor up, and then you're going to blame the nitrous like all the old guys did. The old nitrous burned up my motor. It did not. It's not the motor's fault that you went and stuck too much nitrous in there and melted the thing down. The motor's not capable of handling that. Had you have done the same thing and put bigger heads on it and a bigger cam and a bigger regular factory injectors and put a better computer in there and up the horsepower naturally, say you increase the horsepower 100, naturally aspirated, well, the motor still can't take that. So it's not just the nitrous doing it, it's any type of power adder that you put on there. If you go too much and you go beyond moderation, of course it's gonna destroy it. So keeping jet sizes, anything like that within moderation, these are great little systems and easy to install. You can have these in just a couple hours. Well, here's a neat little item for the late model fuel injected cars. This is your typical fuel injector right here. Most V8 cars, even import cars, run the same style of fuel injector. Basically, it plugs into the intake manifold and the fuel rail plugs in up here, and you have the fuel coming in, it sprays on through. Well, for nitrous systems for these things, there's a great little fitting NOS makes. It's this little guy right here. And what it is you have a fuel inlet and a nitrous inlet on either side, so you can run it either a dry system or a wet system, depending on what kind of fuel injection system you have. And what this does is when you unplug your fuel injector, this has an O-ring down here. You can plug that in, and your injector plugs right into it, just like so. Then, of course, you got to extend your fuel rail up a little bit, but the neat thing with this, you don't have to do any drilling or tapping or messing around or anything like that. And it's individual injection in each port, such as a V8 or say like a Viper. We have a picture of an intake manifold of a Viper where these things are designed on. It's a custom manifold, and it's direct port injection on a V10 like that. Basically, though, when it pulls out, the fuel injector squirts fuel straight out of the bottom here. That's where it, under high pressure, atomizes the fuel, and then it mixes with the air inside the motor, and you get the normal power of the naturally aspirated motor. What this does is it plugs in, and when you look at it straight out of the bottom here, this is where the injector sprays out of the normal fuel. Well, when you're on the nitrous, it's got little teeny orifices all the way around that sprays the nitrous, so it comes out in a shotgun pattern all around the fuel and mixes it in a high pressure and a real high atomization rate, so it burns real well. It's a great little setup for late model fuel injected cars. All right, we're going to go through all the components in a nitrous system. We're going to start with the bottles. I mean, this is probably the #1 icon that you see that advertisers use and stuff. You see the nitrous bottle. Everybody paints them different colors. There's blue ones, yellow ones, white ones, red ones. Basically on bottles, you always want to pick one big enough for your application. But there are different sized bottles for different purposes also. The main thing is, let's just start off with the basics. This is the new Edelbrock one. It's got the carbon fiber look. It's pretty cool. Really neat looking bottle. It's it's kind of important how you mount these things. You always want them, if the front of the car is facing this way, you want the bottle no less than a 15 degree or no more than a 15 degree angle either way towards the front of the car. But you always want the valve pointing towards the front of the car. Reason being is nitrous is a liquid, it's not a gas. So what's happening is there's a siphon tube inside here that comes down and it bends down and comes down to this corner down here. So right on down here, at the very end here, there is a pickup tube. Just like inside of a gas tank, your car has a tube that goes in the bottom of the gas tank. Same thing, because it's picking up the liquid. Well, as inertia goes forward, all the liquid's going to get shoved to the back bottom side of the tank. So you don't want it to be mounted in a particular way where you're starving the motor for nitrous going down the track. But basically, you know, they rate bottles in pounds: 10 pound, 15 pound, 20 pound, 25 pound. This is a typical 10-pound tank. And basically, nitrous is under pressure. It's ideally between 900 and 1,000 pounds. You want no less than 900 pounds. You don't want any more than 1,000 pounds. 950 is just about ideal. And of course, that's temperature sensitive. So meaning that on a hot day, if your bottle's mounted in a hot trunk and it's 110 degrees outside, the inside of that car trunk is probably 140 degrees. That heat creates expansion. Just like a hot soda can. Boy, you put a hot soda can in your trunk and you come back, sometimes the doggone things will explode and burst. Bottles can do the same thing. If you've got a full bottle or it's got a little too much in it, it can build up pressure, and you have components up here that'll take care of that. You got a pop-off valve right here, release valve. And what that'll do is if this bottle gets too hot, this thing will blow and it'll blow all the nitrous out so the bottle doesn't explode. So you want to be sure you don't mount these like inside the car right alongside you, your passenger hanging onto this thing or something. You want to mount it away from it. And if you do have it in the car, in some instances you have to have it in the car, then you want to vent it, run the tube outside. So if it does burst, you're not driving down a road and get asphyxiated, because you know, you take a couple of breaths of this stuff, a couple of deep breaths, you'll die. You'll first at least pass out. Well, then you're passed out at the wheel, and guess what? You're off the side of the road. You're not going to be able to roll down your window fast enough or anything like that. You got 10 pounds in here that's going to come out at 1,000 pounds of pressure. You don't have a chance, okay? So you want to keep this mainly in the trunk or away from you. If it's in a truck, mount it in the bed. Don't put it in the cab. If you do have to have it in the cab, make sure you vent it to the outside. So if it does burst, you don't kill yourself, okay? And worse yet, somebody else. But you have the valve up here. You have a pressure gauge. That just shows you how much pressure is inside for safety. You got the pop-off valve. And of course, on this side, you also have the fitting that you connect the nitrous line to. There's usually a kit will come with like anywhere between a 12 and a 16 foot, what they call a -3 line. That's the braided steel line that runs up to the solenoid. And that'll run underneath the vehicle, attached to the floorboard all the way up to the front of the car where the solenoids are, where the nitrous nozzles are. But all bottles have these basic components. We talk about the downside of nitrous systems before is if it's mounted in the trunk, you got to get out, turn the bottle on, and drive around. And when you want to play, you got a button to play with. But you can't just leave the bottle on all day. Remember I said that before. You leave the bottle on, you decide to get out and go into your favorite food store and eat a hamburger or go get some groceries or something. And what happens is sometimes the solenoids, you got almost 1,000 pounds or at 1,000 pounds of pressure. So what if the solenoid is a little bit old? It's a couple years old and it's leaking a little bit. Well, then you're going to leak that nitrous in that intake manifold, and you go to start the car back up, you could have an explosion. And trust me, when you explode inside the motor like that in the intake manifold, bad stuff happens. Carburetors come off, intake manifolds come off. It's pretty serious. It's violent. So you don't want to do that. So what you can do, there are remote bottle openers. This is one right here made by NOS. There's several companies making these. NOS makes these also. And what this does is it mounts on the top of the bottle, and basically with this electric motor, and you hook it up to a switch on the dash, when you flip the switch, this electric motor actually physically rotates the valve and opens it up for you. So you can be inside, you can flip the switch. When you arm the system, it'll automatically open the bottle. When you disarm the system, it'll automatically close the bottle. That's one way of doing it, just with a mechanical valve opener. Another way is, instead of opening the valve, you leave the valve on all the time, and this is a heavy-duty solenoid specifically designed to hold the pressures of the bottle back. Not just a solenoid up at the front, but one at the bottle. And what it does, this one's, like I say, it's specifically designed for the bottle. So when you turn the bottle on, this heavy-duty solenoid, which is definitely designed to make sure it doesn't leak, opens up and lets the nitrous go up to the solenoid, so when your system's armed, it's ready to go. But you just go ahead and leave the valve open with these. This is an electric solenoid version, where the other one's an electric mechanical. And that's another way of doing it. Otherwise, simple way is just open the bottle and close it when you don't want it. I mean, that's the cheapest, simplest way. For a couple $100, the bottle openers are also a way to go. All right, let's look at another style of bottle. This is also your typical nitrous bottle. Another 10-pound version. Again, they come in different sizes, different weights of and amounts of nitrous inside. On your typical nitrous system, say like 125 horse shot, somewhere's right in there. A 10-pound bottle, you'll get maybe 7 to 10 passes on a quarter-mile run. And again, you're not using nitrous in first and second gear. Maybe 3/4 of the way through second. You're mainly using it in third and fourth gear, or if it's a 3-speed transmission, the upper side of second gear and through third gear. So basically about half track on. So if you've got a 10-second car, you're not on the bottle 10 full seconds. I mean, if you came off the line and hit the nitrous right when you first came off the line, you're going to smoke the tires. If you hit it just when you hit second gear, you're going to make a gnarly second gear burnout. I mean, so you don't want to be on that right there. And the object of a good quarter-mile time or a good speed time is to not spin the tires. You want them to hook up. So, but just so you know, an average system like this on a 10-pound bottle, 7 to 10 passes average. Of course, there's so many variables, jet sizes and things like that, temperatures, if you got a higher pressure, lower pressure. There's so many variables involved. On a big system, like a 250 horse shot system, you're going to get maybe 3 to 5 passes, which isn't a whole lot. So you want, on a system like that, you're going to want like a 20-pound bottle. So instead of 3 to 5 passes, you get 6 to 10 passes because you're using a lot more nitrous. The jets are bigger, you're flowing a lot more fuel and nitrous, so the supply doesn't last very long. I said it before, it's a good idea to have a spare bottle because taking them down, getting them filled, it's not very expensive, but it's a hassle. And if you got a spare in your garage, man, you can just swap one out. Or better yet, run 2 bottles. Some vehicles will have twin bottles mounted in there, and it just saves having to change one or the other. Some use 2 different systems and they run 2 different bottles for each system. It just depends on what you're running. This bottle right here, again, is another 10-pound bottle. It's got a typical regular valve on it. Some valves have high flow valves, some are standard flow valves. On the bigger systems, like a dual stage fogger system, you're going to want a high flow valve because you got 8 or 16 jets, depending on if it's a 2-stage system and what we call a hard plumbed 2-stage system or even a 3-stage system. You got a nozzle going for each cylinder. All right. Well, if it's a hard lined 2-stage or 3-stage system, instead of 8 lines going into a V8 engine, you got 16 fuel lines because there's different nozzles. So boy, that's a lot of flow. So you better have a 20-pound or a pair of 20-pound bottles laying around for a system like that. You wouldn't use a 10-pound bottle. You'd barely get 2 passes out of it, if that. So on the bigger systems also, they run the high flow nozzles. This is your standard flow nozzle. It doesn't have a gauge. Anytime you don't have a gauge on the bottle, which most basic kits don't come with a gauge, it's a good idea to buy one. Here's your just basic inline gauge. You can buy these, any supply place, Nitrous Supply, any places like that will have these. It just mounts inline. Here's your -3 AN fitting on this side and another -3 female on this side, and it just mounts inline so you can monitor the pressure inside the bottle. And that's a good idea because as the pressure gets low, if you get down to 20% of volume inside the bottle, your car's going to start surging down the track. So anything as it starts getting down in this area and you make that last pass, when the pressure gets low and the volume gets low, you hit the throttle and the car kind of goes, you start surging a little bit. It's because it's not enough pressure and everything to keep it going, and you'll notice a surging effect, and that's pretty normal. We talked about pressures inside the bottle and heat being a factor. Well, cold's a factor also. And you always need a certain amount of pressure. Well, obviously, if it heats the bottle up, like on a hot day, you increase the pressure. Guess what happens when it gets cold? The pressure decreases. So optimum, you really want the bottle to be at about 80 to 85 degrees, no less than 80 degrees. 85 is about optimal. Okay, on a hot day, obviously, it's going to get 90, 95, 100 degrees, where your pressure is going to increase, and you risk blowing that pressure valve off, the safety release valve. So you want to be careful of that. But a lot of you are in cold weather. Not everybody's in a nice, sunny, warm area. So for places that don't have sunshine on the summer days when you're out cruising around or something, there are bottle blankets. What this does, it just keeps the bottle insulated and warm and the elements off of it. These are really inexpensive and just a way to go. Nitrous Oxide Systems makes one. They're blue. Edelbrock has their red one. A lot of times they're color-coded to match their bottles. They're inexpensive, a good little setup to go. For really cold weather, there are bottle heaters. And basically, it's like the defroster on your rear window. You push the button and you got the little fine line filament wires inside your window. They have those for around a bottle also. You can push it and it actually warms the bottle up to about 85 degrees. That keeps an ample amount of pressure in here so it works. All right, let's talk about this little bottle right here. This is what they call a Sneaky Pete bottle. The reason they call it a Sneaky Pete, a lot of people use these for cheating. I've seen drag guys mount these where they have a dry sump oil system. They'll put a wet sump pan on there and mount this little guy inside the oil pan, put it back up there, button it back up on, and cheat while they're drag racing. You'd be surprised what people do to cheat. I've seen pressurized roll bars where they got the whole roll cage pressurized and filled with nitrous oxide, and they hide the lines. It's pretty amazing what people do. They use these systems also for hidden systems where it's plumbed underneath the manifold. You flip the intake manifold upside down, you can see all the hardline plumbing in there, and the lines come out hidden out the back of the motor between the manifold and the block. Little bottles like this can also be used for motorcycles. They can be used for all kinds of little things, not just cheating, but it's amazing how many people, you'd be surprised at who's cheated over the years with nitrous oxide. Just little amounts, not enough, but just enough to give them another 5 or 10 horsepower just to get on that edge. And it's not just drag racing, it's in road racing, I mean, all kinds of things. You'd be surprised. It's funny, one of my old buddies from years back, he's one of the co-inventors of the GoPed, and he had a little GoPed at his shop one day, and it was water cooled. It was a little built aluminum engine, and he had this little nitrous bottle. And I said, wow, that thing's really cool. He goes, yeah, I'm going to test it out. About a week later, I saw him, and he's all banged up. He's got scabs all over him, and it's just scuffed up real bad. I said, man, John, what happened to you? And he goes, I tried my GoPed out. He had a 5 horsepower shot on this little teeny scooter, and which, you know, the motor itself doesn't even make 5 horsepower. I think it makes less than 1, you know, maybe 1.5 horsepower. There's a little teeny 2-stroke thing. And he said, oh, I was going along about 15, 20 miles an hour, and I hit the nitrous, and the thing shot out from under him, and down the road he went. So you can use nitrous on all kinds of crazy things, but it's interesting what you can find these guys putting them on. But motorcycles are getting popular for nitrous, snowmobiles, ski-doos, you know, jet skis and things like that. But that's what these little bottles are for mounting for little systems like that. They're basically the same thing. They've got a little valve on top. They have the little fitting over here where the -3 line goes into. And they're a lot simpler systems, but they still require a typical bottle with a valve, a solenoid, and a little nozzle system, and off you go. You know, one question you might want to ask is, hey, where do I get my bottles filled when I run out? Or if I buy a nitrous system, how am I going to get my bottles filled? You know, I don't have a speed shop in my area. Well, a lot of speed shops do fill bottles, but another place that does fill bottles are welding supply stores. Any place you can get oxygen or acetylene or argon gas for wire feed welders or anything like that, most of those places fill nitrous bottles, and most towns have some sort of a welding supply store in, and they carry nitrous oxide most of the time. So you don't just have to go to a speed shop or go to the next town to find one. I'm sure you probably have one in your town or really close by, and you can get your bottles filled there. We're going to talk about the different systems that are available as kits. This one right here is from Edelbrock. It's their Performer system. This is their lesser expensive system just for your basic street vehicle or maybe a street strip weekend fun toy. These are available for like 50, 75, and 100 horsepower shots. Nitrous Oxide Systems has one similar to this. It's called a Power Shot. These use the smaller solenoids because you don't need the great big solenoids for flowing big fuel numbers or big nitrous numbers. So these use the small solenoids. They're kind of an economy solenoid, but they work fine. Nothing wrong with the quality. They come with the bottle brackets to mount the bottle. If you look, they come with pretty well complete with everything you need. Of course, I don't have the bottle here. It's in the box. I just want to show you how they come. You get the relay for when you turn the arm switch on, and then you activate the system. This is the relay that activates the solenoids. We've got a little pack of jets right here, various sizes for the different power levels. You got the fittings, the lines. You got a nitrous line here, a fuel line up here, brackets to mount the solenoids in. So you can mount them off to the side. They mount right on the edge of the carburetor plate. You get the plate system, and it's already set up with the red one over here, and it says fuel on this side, and you got the blue fitting over here, and it'll say nitrous and which way is up on it. You get between 12 and 16 feet of line to mount the bottle in the trunk. And you know, this is a nice little system. This is a wet system, so it means it flows nitrous and fuel, and it's for your basic square flange carburetor, from like anything from your Edelbrock carburetors to your small Hollies, from like the 600s on up to like 850, even double pumpers. Just a basic, what they call a square flange system. These are a great little inexpensive, entry-level, fun kit to get. Well, this kit right here is the next size up. This is Edelbrock's Performer RPM kit. which is also equivalent to the nitrous oxide cheater system. Basically, it's a little larger kit. It's got the larger solenoids. They're a little better flowing, a little more heavy duty, a little more expensive too. This kit's a little bit more than the smaller kits. This one's rated between 100 and 250 horsepower. So the smallest shot that this kit comes with is 100 horsepower. So you're not going to be wanting to put this on your Honda Civic or something like that unless you want to blow your crank out the bottom, or unless you got a built motor. But as far as like an American muscle car or something like that, this is ideal, you know, for a big block or something like that. This thing's perfect. Or if you have a built motor that's got a forged crank, forged rods, forged pistons, and extra clearances added for it, you could get up into the upper power shots of this, of the 200 and 250 horsepower area without too much of a problem. But on a stock motor, I wouldn't recommend this kit if you're just a bone stock motor. The smaller systems like the Power Shot or the Performer would be best suited for that. But if it's a built motor, the RPM kit or the Cheater Series kits, those are excellent. And again, it's got all the same components as the last kit had, just larger solenoids. Everything else is pretty much identical. It's the same spray plate, same lines, same solenoid mounts, same fitting, same everything. Just a little bit more power is available through this kit than was on the last one. Now we're going to talk about dual stage kits. And what is dual stage? What does that mean? I'm sure you heard the term single stage or dual stage nitrous kits. Basically, you know, when you activate the nitrous button and you're going down the track, the solenoid's open and you're spraying fuel and air inside the motor. That's fine and dandy, okay? Well, on a higher horsepower shot, say 250 to, say 350, 400 horsepower shot, you can't go pushing a button and unleashing 400 horsepower or 300 horsepower all in one shot, or even if you're 3/4 track. I mean, that's like all of a sudden turning on another hot little V8 under your hood, turning it on. Well, what's going to happen? The tire's going to smoke. All of a sudden, you're going to break the car loose. And trust me, breaking the tires loose at 110, 120, 130 miles an hour, that'll pucker your butt. Okay, you don't want to be doing that. All right. So what two-stage mean is when you activate the nitrous system, a first stage comes on and it unleashes like 100 horsepower, somewhere's right in there. And then with the delay box, and what that does, an electronic delay box, it'll hold the amount of delay time for the second stage to come in. When the second stage comes in, it might release another 150, 200 horsepower shot. So your power level comes on medium and then strong, instead of all at once, bam, all of a sudden coming on. So you can adjust the delay for how long it takes for the second stage to come in. But basically, it's usually about 100 horsepower initial shot. That's the first stage. And the dual stage system is when that's on and the second stage comes in, which is a higher amount of horsepower. Let's check one out here. This is a kit from Edelbrock. This is a dual stage system. It is not a fogger system, though. This uses a plate. And we'll kind of go over the components here. If you notice, it's got 4 solenoids. Basically, what that is you have a fuel solenoid and a nitrous solenoid for the first stage, okay? And then the second stage will come in with the second fuel and nitrous solenoid, and that releases all the amount of power, the full amount of power. Well, a kit like this kit's rated up to 400 plus horsepower. That's a lot of horsepower, okay? I mean, you're talking, if you had a typical small block Chevy that makes 400 horsepower and you put one of these on here, you're going to immediately go to 800 horsepower. That's sprint car and NASCAR kind of horsepower, okay? If your motor's not built for that, kiss your crank, rods, and pistons goodbye. You're going to blow head gaskets and you're going to blow a crank right out the bottom of the motor. This is not a kit for your average street guy. You better have a built motor for this, okay? And it better be set up, because that's a lot of power, that's a lot of cylinder pressure, and a lot of heat that's going to go inside that motor. And if it ain't set up, kiss it goodbye, okay? So only for your serious guys out there is a kit like this designed for. But it's got your basic things, gives you plenty of line, comes with all the lines needed to mount the solenoids and plumb those in, your typical bottle mounts. And on something like this too, you're going to want a larger bottle. You're going to want a 15 or a 20-pound bottle with something like this. A little 10-pound bottle with this much nitrous flowing through there, it's not going to last very long. You're getting about 3 passes down the track and you're empty. Okay, that's no fun. On the street, shoot, you're on the nitrous more on the street than you are at the track. On the track, it's only half track on, and you're only doing a 1/4 mile. A lot of you East Coast folks out there, you don't have 1/4 miles, you got 1/8 mile. So you're not on the nitrous for very long. Well, on the street, every freeway on-ramp's a racetrack, you know, and you know you're going to do that, so don't say you won't. Every time you're going to pass somebody, you're going to be on that button with the nitrous unleashed. So, you know, anytime you unleash that nitrous, you're draining the bottle out, so you better have a big enough bottle. So go through the components here. Basically the same stuff that's in all the other kits. Of course, you get 2 more brackets to mount the nitrous solenoids. And on the plate right here, there's a little different on this plate as opposed to other plates. If you notice, there's 2 lines coming in for the fuel side, and over here there's 2 lines coming in from the nitrous side, because the first stage comes in on one side, and then when the second solenoid's up, they flow through the second side over here. Okay, so you got two fuels, 2 nitrous lines. So depending on which solenoids are open is which fuel line is activated at that time. And obviously the spray bar is a lot larger. It flows a lot more. It's designed to flow enough nitrous and fuel to support that kind of power. Okay, and basically all the fittings and the same jets and everything like that. Like I say, this kit's adjustable from 100 to 400 horsepower. That's a pretty good fun factor there. This little system right here is designed for sport compacts. It's a dry system. It's a very simple little system. This is from Edelbrock. We'll look at it right here. And dry systems we talked about before are very simple. It's just a single solenoid, a single nozzle over here that just sprays nitrous-only spray. There's no fuel being delivered. So for sport compact cars or anything like that, this is a really slick little system. It installs literally, I mean, just in a couple hours and you're down the road. But let's go over the components of this also. You get your line to mount your tank in the back, in the trunk somewhere. You got the bottle brackets, and of course you get a bottle with it also. We got the relay right here, the electric relay to control the solenoid. All right. If you look down here, this one actually does have 2 solenoids, and the reason being is one's a safety solenoid. One controls the nitrous coming in. All right. And so when you turn your switch on, one solenoid turns on. The second solenoid though is activated if there's a little guy over here. It's a fuel pressure switch. So the second one, as long as you have good fuel pressure, this switch is on. Okay, so as long as you got good fuel pressure, this is on. So the second one will say, as long as the fuel pressure, the second one will say, okay, I'm able to turn on. If the fuel pressure drops, this one turns off. So you may have the button pushed and this solenoid might be on, but as long as you have ample fuel pressure, the second solenoid will stay on. The minute fuel pressure drops for any particular reason, fuel pressure regulator problem or anything like that, this guy right here will shut off and not allow the nitrous system to work. So it does have 2 solenoids, even though really you could unsafely get away with one. This is just a safety feature that Edelbrock has built in. It's a pretty good idea to have something like that. You look at other components. You know, you got bottle adapter fitting to go from the bottle to the lines, the solenoid brackets and goodies like that. All the little fittings you need. Of course, you got the nozzle that goes in. There's a nitrous pressure regulator right here, just regulates the pressure for the nitrous. They even give you the tap, the 1/8" pipe thread tap, because all you do with this nozzle right here is your air inlet tube inside the car. Sometimes they're plastic, sometimes they're aluminum or metal. You just drill a little hole in it, run the 1/8" tap in it, screw the little nozzle right here in, and you just make sure that the fan spray on this is facing so it sprays towards the engine, towards the intake of the fuel injection system. And that's it. I mean, it's a simple little system and off you go. Inexpensive, great bang for the buck. These are great little systems. All right, we're going to talk about another system here. It's called a top shot system. It's kind of a hidden system. This little motor has one right here. You really don't see anything. You don't see solenoids too much. You don't see lines all over the place. But actually hidden underneath the air cleaner right here is a full-on nitrous system. There's a solenoid up underneath here for the fuel and one over here for the nitrous. And what happens is it comes up and sprays right straight down inside the carburetor. It's kind of a neat little hidden system. If you look, there's the activation switch right down here, and that's for when you give it the throttle, it will activate this switch and send the nitrous system. Actually, we have this one activated. We can show you what it looks like. Of course, the engine's not running right now, so it went up, but under full throttle, when the air and everything's going inside there, you give it a shot, off it goes. Let me give you a little tidbit of information too, just on the top shot systems. This one right here, we have a mechanical secondary carburetor on. You want to be sure you do not use vacuum secondary carburetors with a top shot system. It's just more of a safety feature. So you want to use like a Holley double pumper or something such as this Edelbrock carburetor right here. Reason being is vacuum secondary carburetors, you can stab the throttle at a lower RPM and the secondaries won't open until the velocity gets to become enough to actually open the secondaries. Well, if you're on the nitrous system before the secondaries open, you can go into a lean condition or have a buildup of nitrous in the top of the carburetor area. Instead of it squirting down the throats, if you got 2 of the throats closed, it builds up in here. That's not a real good idea. So other nitrous systems, it's okay really to use a vacuum secondary carb if it's a plate underneath the carb. But on the top shot like this, you shouldn't do that. Make sure it's a mechanical secondary. You know, a lot of you have turbocharged cars or supercharged cars. We're going to talk about that next. You know, nitrous oxide is cold. It's well below freezing. In fact, it's well below 0. as you just saw in the Chop Shot system. It's ice cold coming out of there. So with turbocharged cars or supercharged cars, it can be used as an intercooler, being that it's so cold. Basically what happens is, here's an inlet tube right here. This is actually off one of my old cars. It was a supercharged small block Ford. And basically what happens is this is the air inlet tube to the Paxton supercharger. And what I used to do was inject nitrous inside here, and it would act as an intercooler. So the inlet air charge coming inside, say it's 80 degrees outside. All right, well, you got 80 degrees coming in the front of the car going into this tube. When you hit it with nitrous, it can drop the incoming air charge down 65, 70 more degrees. So, you know, you're down to 10 or 20 degree air coming in. Well, that makes a denser air charge for the supercharger to compress and put in the motor. Well, that in itself makes more power. Now, mind you, on a carbureted engine, you got to meet that when you turn the nitrous system on with fuel at the carburetor. So you still have to have a fuel solenoid too. Just to give you an idea, my system was two systems. I had this as an incoming air charge to cool it and to oxidize the air coming in. So you get a denser air charge, plus it's highly oxidized. It would get compressed by the supercharger, then go into the carburetor, and underneath the carburetor was a plate system. And on that, the fuel solenoid was adjusted to meet the nitrous for the solenoid at the carburetor and the nitrous for here, plus the extra shot of nitrous coming in. It was just serious power. On late model vehicles like turbocharged import cars or supercharged cars, American cars or anything like that, they're fuel injected. Most of the time they're fuel injected. So being that, the fuel injectors adjust, the computers and fuel injectors adjust for the incoming charge. So you can use this before the cooler, it's like before the turbo, so it's like an intercooler. So when the incoming air charge comes in, that turbo can compress more air, and it's oxidized air, so it's highly oxygenated, which makes it compress more. Incoming charge is cooler, so it's actually making the turbo work better. It's actually putting out more boost, more volume, because the air is denser coming in. The O2 sensor detects that and says, okay, here's more fuel to meet that. So you do it on the fly. It works really well. But that's what this system is. The nitrous line came up right here, came in, solenoid would turn on, it would spray into a little nozzle inside here and just direct the cold gas spray right into the supercharger. It's a really slick little system. It works for American cars, import cars, carbureted fuel injection. Of course, fuel injection being better because it does it on the fly. Carburetor is a little more tricky because you got to check the air-fuel ratio coming, or the mixture coming out the tailpipe, and make sure you jet accordingly. Because if you lean it out, if you just tried doing this and didn't meet it with fuel, and you tried leaning it out, you just melt the motor down. I mean, you know, the oxygen, we showed that earlier. Oxygen makes heat. It leans it out and creates more heat. So you don't want to do that. You want to be sure anytime you add nitrous, you also add amount of fuel to it. Like I said in the very beginning of this, nitrous isn't what gives you the horsepower. It's the fuel. Nitrous just allows you to burn more fuel. No brainer to horsepower. Raise cylinder pressure. Anytime you can add more fuel and air into a cylinder and get it to burn efficiently, and it's good atomized fuel inside there, you're going to make more power. It's a no-brainer. The more pressure you put in there, the harder it turns the crank, harder the crank turns, the more power out to the wheels. Real simple. Well, this big monster right here is a Wyand, a 671 blower, or sometimes called a supercharger or a huffer. For you guys that really like the forced induction, there's nitrous kits for these too. And the question is, can you run nitrous with a blower? Sure, why not? One power adder, let's stack another one on top of that and make even more power. This one right here is made by NOS, Nitrous Oxide Systems. It's capable from 80 to 200 plus horsepower just right out of the kit. We'll look at some of the components. This is how the kit comes. Just like any other nitrous oxide kit, you get the hoses that they give you to go from the trunk all the way up to the unit here. They give you the hoses for the solenoids, all the electrical, and of course this uses the large solenoids, the really good ones that are a lot heavier duty. So this is a good kit. These really aren't that expensive for what you get. I mean, there's a lot of work that goes into bending all these lines, and they come this way. This is a show one here. It's all polished, but they come this way, so you don't have to bend all the lines. If you ever want to get something like this and you can't bend the lines, you can give someone like Nitrous Supply a call, and they'll be glad to do it for you too. They have an 800 number that you can call, and they'll be glad to bend things up for you and do this. But this kit comes this way, and we'll take a look on the inside next. I'll pull this off here and do these screws. Let's pull this whole unit off. And here's what's inside. Just like most nitrous systems we talked about, red is fuel, blue is nitrous. So when you're looking at the way the lines are made out, some people might look at it and go, man, what a bunch of spaghetti. It's really simple. If you look back here, there's a red fitting back here, and there's a blue fitting back here. So the blue being the nitrous, red being the fuel, each individual line comes up, and you can see each nitrous nozzle and each fuel nozzle that comes up. And it sprays down inside with these little nozzles. They're like a fogger style nozzle. We can tilt this up. You can see inside, and it sprays down inside the blower with both fuel and nitrous. And again, these are adjustable from 80 to about 200 plus horsepower. Of course, you could probably jet it up for bigger than that if you wanted to get larger nozzles, but for fun on the street, on top of a supercharger, on a small, this is a small block Chevy setup, so you're talking an instant 500-600 horsepower, add another, between 100 and 200 horsepower on top of that. I hope your lower end's strong enough to take it, because that's going to be a lot of jolt on the bottom end. All right, I thought we'd talk a little bit more about this 671 blower system and kind of compare it to other systems. Give you a little close-up of this also, a little better idea what's going on with it. We'll flip it up. Each one of these is its own nozzle. So of course we talked about that before. Each blue one is a nitrous nozzle. Each red one is a fuel nozzle. Well, if we flip it over, you can see how these spray. And come over here, and you can actually see that there's a little orifice right here for the nitrous and a little orifice right here for the fuel. What these do is they atomize fuel a little bit better and they atomize nitrous a little bit better than the spray bars do on plate systems. So when you have a typical plate system, you're only coming out just a hole, where these actually deflect the gas and the nitrous straight down into the supercharger. Or if you have a fogger system or something like that on an intake manifold, these are directional. They spray it downward. Where a spray bar, they do spray downward also, but they don't quite atomize the fuel and the nitrous as well. And we talked about this before. The whole key to burning fuel or nitrous is to atomize it. Well, you can't really burn liquid fuel, so you're really trying to get small droplets, and the smallest droplets you can possibly get, the better. Just more surface area. It burns better, burns faster. So that's what these nozzles do, as opposed to like a spray bar or a plate system. Another thing too, we're looking at jets on this. This is a nice kit, and they look great, but they're a little more complicated for changing power levels on, because each individual runner here has its own jet. Inside each nozzle here is its own jet. So you got 8 nitrous nozzles and 8 fuel nozzles, and you certainly don't want to mix up the jets in here. And when you're going to replace 8 fuel jets, you want to just do all the fuel jets at a time, in one row or at a time. And same thing with the nitrous ones. You want to go all through and just do the nitrous. You don't want to mix and match and accidentally put the wrong jet in the fuel or the wrong jet in the nitrous, because you could lean out the fuel and you might have a little problem. One last piece of information I'd like to give you on this system right here is where to mount the solenoids, and that's pretty much with any system. This particular 671 kit obviously is going to be up on the supercharger, which is high up off the motor. And you got carburetors up there and other fuel lines and things like that going to the carburetors and stuff like that, or the injector hat. You might have fuel rails or fuel lines going to those also. Rule of thumb is you always want to mount the solenoids as close to the plate or as close to the distribution block as you can possibly get. So these always go towards the motor, not towards the back of the car. And it's not just with this system, it's with any type of plate system. It could be a cheater system or a power shot or a performer RPM, a dual stage, it doesn't matter. That's why on a lot of intake manifolds you'll notice that the solenoids are mounted right on the manifold, as close as you can possibly get. So the closer the better on those. Well, I've said earlier that nitrous is cold. Well, below freezing actually. Well, how far below freezing is it? It's minus 89 degrees Celsius. So that's way down there. I mean, that's really, really cold. The reason I'm telling you this is because it ices up. It causes icing problems inside of plates and inside of nozzles. So the longer you have the button on, the more chance you have of it icing up along the spray bar. Or if you have a nozzle, like a fogger nozzle or just a standard nozzle, they'll ice up right along the edges of the nozzle here. And what will happen is, nozzles you don't have too bad a problem, but on a spray bar it can ice up and block off the fuel or the nitrous being released into the motor. So you got to be careful with that, because if you block the fuel off, you're going to lean the motor out. What's the #1 rule of safety in nitrous? Don't lean the motor out. So the longer you have the button pushed, the more chance you have of icing things up. That's another reason to use nitrous just in short bursts. This is one of those little sneaky Pete systems. This is for you guys that want to have some fun without your buddies knowing you have nitrous. You can hide this little teeny bottle somewhere. And these are good for like 20, 25, 30 horsepower increases. And we're going to kind of look at the little kit, how they come here. They're really simple. I mean, this is the easiest kit in the world to install. You get a little hose clamp for the bottle, and again, you can hide this thing anywhere. It's really, really slick little setup. You get all the wiring that you need, and these are the nozzles. I mean, there's just a little 1/8" pipe thread on one side with a little teeny orifice on the ends. One's a straight shooter, and one's a 90-degree shooter. So you can just kind of hide these in your intake manifold. It's just an 1/8" pipe. So you drill a hole, tap it out for 1/8" pipe thread, screw one of these guys in, And there's your nitrous spray. They even give you the tap and the fittings and everything to do that. If you look, it's got a little teeny solenoid. It's got one of the small solenoids on it. So this too you can hide up underneath your air cleaner or anything like that. No one would really even know you have this. Now what you don't see here is a fuel solenoid. These don't use fuel solenoids. All you do on this, being it's such a small shot of power, it's only 20, 25, or 30 horsepower, you just upjet the carburetor, and there are formulas that you get with the instructions on this that'll tell you how far up to jet it and how much to increase the fuel pressure, so when the nitrous is on, you're still safe. If it was any more than a 30 horsepower shot, you definitely wouldn't want to do this. You'd want to put an extra fuel solenoid on there. But just by richening up your jetting on the carburetor, you can get away with this and get a little advantage over your buddy, and when you blow his doors off, he's going, man, how the heck did he do that? You got one of these hiding in your car, that's why. All right, we're here at Nitrous Supply in Huntington Beach, California, and we're looking at direct port nitrous systems, or direct injected nitrous systems. We're going to look at two different types here, two different types of manifolds, and two different types of systems. The first system we're going to look at is a single stage system, kind of like your typical plate system, only it directly injects the fuel and nitrous right into the intake runners, or ports. That's why I call it a direct port system. And they run these fogger nozzles right here. Well, they spray a very dense and a good amount of dense fuel and nitrous right directly at the valve, intake valve going into the heads. Well, this is a single stage system right here, uses two solenoids. Of course, the red solenoid is always fuel, blue solenoid is always nitrous oxide. And if you look down here at the fittings, all the red fittings here are all fuel, and the blue fittings, that's the nitrous lines coming in out of the nitrous solenoid. It's a real simple system. It works just like a plate, but instead of injecting it through a spray bar, it injects it into each runner, which gives you better tunability per cylinder, and obviously you can make a lot more power. These things flow a lot of fuel and nitrous. Well, the whole key to horsepower is burning fuel. Stuff more fuel in there, hit it with more burnable air, oxygen being the nitrous oxide, more power. This is a single stage system, so when you push the nitrous button, bam, these come on, you flow what you're going to flow, and that's that. When we come over here to this manifold right here, this is a sheet metal manifold on something you'd find on a Pro Mod car or just a hardcore drag racer, something like a 622 cubic inch or a 700 cubic inch motor. You're talking 2,000 plus horsepower on these babies. This system right here is a dual stage system. Looks like a lot of spaghetti. It's not. It's actually laid out very precisely and for a reason. If we look here, let's kind of go over the basics of it. It's a dual stage system, so obviously it's got more than just the two solenoids. So we look here, and here's the two first stage solenoids. We have another blue one right here, that's the nitrous oxide. We have a red one, that's the fuel. Well, if you look at, let's just take this nitrous oxide solenoid. If you look at that, it comes out and goes into a distribution block, or sometimes they call it a manifold, a fuel manifold or a nitrous manifold or a distribution block. That just allows it to go in with one outlet and come out as many. So if we look at this solenoid right here has these lines coming out of it that go into these outer nozzles right here, the foggers. And they also go to the inners one right here also. Obviously the blues, those are all nitrous oxide. The reds all come off the fuel solenoid. So when you hit the nitrous button, this first stage kicks in, that dumps like 250 horsepower to a 300 horsepower shot right into the manifold. Then through a control box, through the timer on that, that'll tell you when the next stage comes in, which might be another 300 horsepower. And you're saying, well, Aaron, what the heck would you want to do that for? Reason you'd want to do that is because, let's say you're going down the racetrack and this is a 600 horsepower system. You hit the button and you instantly have 600 horsepower kicking in a butt. Well, guess what's going to happen? The car's going to break the tires loose, and it's going to turn around sideways, it's going to end up upside down or dead. So you can't just hit it all of a sudden with 600 extra horsepower. You got to come in on stages so the tires don't break loose. So that's a dual stage system. But if you look at it, we have the first stage solenoids right here. If we get down inside here, get a close-up of this, you can also see solenoids down inside. This is just the second stage, and of course they do the same thing. They have lines coming out of them with both the fuel and the nitrous oxide. So it's a real simple system. They all work about the same. It's just single stage, double stage, there's even three-stage systems. And then to add to the spaghetti look of this, it's the fuel lines. So you're looking at a lot of stainless steel lines right here. The fuel lines are right here where the fuel regulator is. So your main fuel inlet line comes here from the fuel pump, and it's going to the fuel pressure regulator right here. The pressure is regulated to a given amount of pressure, usually 7 or 8 psi on a Holley. And then it comes right on out here and gets distributed to the Dominator carburetors. So when you're looking at it, if you didn't know what we were talking about, you'd look at it and go, God, what a bunch of spaghetti. Man, that stuff's complicated. It's really simple. It's just, you're going to have the fuel lines anyway. You're going to have 2 lines on each side going to the carburetors. Well, even if you had 2 solenoids here, you go into direct port fogger nozzles, you're going to have however many cylinders you have. If you're going to each one, you're going to have that many lines going to each runner. So you're going to have, if you're running a 4-cylinder, you're going to have 4 lines coming out of here going to each runner, and 4 lines coming out of this one for the fuel going to each runner. So that's 8 lines. Being it's a V8, you're going to have 16 of these things. So it looks like spaghetti, but it's really laid out in a way that's actually very simple, and it works very simple. It works like all other systems. It's a really killer system. You know, a question I get asked all the time is, hey Aaron, what's that nitrous I see spraying, or what's that fog I see spraying up by the windshield on some of the cars that have nitrous? They see it at the racetrack or sometimes on the street. And what that is, that's someone that has a purge valve kit installed on their car. And basically what that is, here's one right here from Nitrous Oxide Systems. You can get these, they're very inexpensive, and basically what this kit comes with is a solenoid and a T-valve and a couple little fittings and of course a piece of tubing and a push button to activate it. And it's a simple little system that basically all it does is this valve right here. Let me show you a system. Here's your typical plate system. All right, so we have the solenoid that comes up, and remember, blue is the nitrous, red is the fuel. So we come over here, and this is the blue side, and this is the blue nitrous solenoid. So what happens is this line right here that comes from here goes all the way back to the bottle that's mounted in the trunk or in the back of the car somewhere. So when you activate the bottle, you open the valve on the bottle, you got about 15 feet of line that is forcing up liquid nitrous oxide up to this point right here. Well, if your bottle's been on for a while, or even if you haven't had it on for a while and you turn it on, it compresses air inside there. Liquid doesn't usually get to the solenoid right away. Let me kind of give you a scenario. Let's say like you're at the racetrack and you're racing a guy that's alongside you that is just as fast as you are. I mean, you really need that edge to get in front of him. Well, what a purge valve kit does is it mounts right next to the nitrous solenoid itself. As you can see, it has a T-valve here. It'll mount right on here. So when that's installed and you wire it up to the switch, you can mount this line and bend it anywhere you want. You can bring it on up. Some guys bring it up to the cowling right by their windshield wipers. So what happens is when you push the button, it releases air in the line and makes sure that good ice-cold liquid nitrous oxide is up at this solenoid. So the instant you hit the button, it's only got an inch to go before it's at this solenoid. Well, what can happen also is you've had your nitrous on for a while, you've been driving around all day. Well, what can happen is the line, the liquid nitrous oxide in the line can turn back to a gas state. So it's not a cold liquid anymore. It's heated up and it's kind of changed forms into a gas. So when you hit your nitrous button, that has to force from the bottle again liquid right on up. And in the meantime, for a split second or maybe a half a second or something like that, instead of cold, wet nitrous coming through the spray bar here, what you get is a little bit of air or not quite as good. So here we go back to that scenario. You got a guy alongside you that's almost as fast or just as fast as you are, and you need that edge. Well, when you hit your button on the track, if you have a half a second of delay because the nitrous coming out wasn't ice cold and wasn't liquefied, you're not getting the advantage of the nitrous. So when you purge, you spray, and you'll see him at the track doing that. That just gets rid of all the gas state or air in the line and make sure that when you hit that button, it's a nanosecond before the liquid nitrous oxide goes into the motor. So that's what that kit does. It just ensures that you get an instantaneous shot of full nitrous, and then you have that advantage on the guy next to you. If he doesn't have one, when he turns his bottle on and pushes the button, he might have a half-second delay, and you didn't. Well, now you got the jump on him, and you might win the race. Now we're going to talk about the fuel system. Fuel system is very, very important, and the #1 rule of any fuel system, never lean out a nitrous motor. As we showed with the oxyacetylene torch, we had the acetylene on, makes a nice cool flame with the acetylene, yellow flame. As soon as you hit with the oxygen, blue flame, instant heat. Well, same thing inside the combustion chamber. You go throw a nitrous in there with not enough fuel, that means you're running lean, instant heat, and the internal components can't take that. So you want to be sure you have adequate fuel in with the nitrous. Remember, the whole key to nitrous isn't burning the nitrous itself. It doesn't even burn, it's non-flammable. It's burning the fuel. And if you don't have enough fuel in there, the heat's going to go up. So you always want to be slightly on the rich side. You never want to run a nitrous motor lean. You always want to be slightly on the rich side. So anytime you're tuning or anything like that, or you're jetting and you're kind of looking at spark plugs, which we'll go into in a little bit here about jetting, but you're looking at things like that, if it's borderline lean or borderline rich, always go to the rich side. Never lean one out, because even temperatures, air temperatures and things like that, and ambient temperature outside can mess with your tuning. Let me give you an example of that. We talked about bottle pressure before. 900 to 950 pounds to 1,000 pounds, anywhere in there is ideal pressure. Well, let's say you're checking your jetting on a day that's 70 degrees outside. Well, 70 degrees, that bottle pressure might be at 900 pounds per square inch. All right, so when you activate your solenoids at 900 pounds per square inch, it's forcing nitrous into the motor. Well, that's fine, okay? Let's say you do it on a hot day. Now the bottle pressure's at, the bottle temperature is at like 105 degrees because it's hot inside the car or hot inside the trunk. Now that bottle pressure's up at 1,000 plus. So when you activate the system, you got another 100, 120 pounds of pressure forcing that in there. Well, hell, that's a lot. That's like your air compressor with a blowgun. That's a lot of pressure coming out the blowgun. Well, that's how much more you increased the pressure. Well, the jetting in the carburetor, especially on a plate system, never changed. The jetting on the plate itself coming in from the fuel line never changed, but the pressure did change coming from the bottle. So you really got to be careful of that. If you're going to check jetting, do it on a warm day. Do it when the bottle's at its maximum, so you know, look, at any given time, no matter how hot it gets out, this is as lean as it can possibly get because the bottle pressure is as high as it can get. It's okay to run it a little on the rich side. But if you jet on a cold day, sure enough, on a hot day comes up and you think your jetting's good, you're going to be in trouble, okay? So just be careful of that. So we're going to talk about the fuel system. First, number one thing is, people ask, man, when I put my nitrous system on, do I have to rejet my carburetor? Do I have to do anything to my fuel injectors? No. Reason being is, especially on a carburetor, the carburetor is completely separate from the nitrous system. So you're driving around without the nitrous on, you never changed anything. When your nitrous system is not activated, you didn't change anything in the carburetor. You're still driving around on the same settings that you had before. So if you weren't lean or too rich before, you're not lean or too rich now. The nitrous system, especially on a plate, has its own nitrous solenoid and jet and its own fuel solenoid and jet. So that's completely independent of the carburetor, and it's also completely independent of your fuel injection. Because the fuel injection, you're going to put a dry system in, you're going to hit it with nitrous, the O2 sensor is going to pick that up and say, oh, I'm a little lean right now, and it's going to throw in extra fuel and compensate for it. Up to a point. Obviously, if you go putting a 200 horsepower shot on your 120 horsepower four-cylinder motor and you add another 200 horsepower on it, the computer and the dwell time on the fuel injectors isn't going to be able to compensate for that. So that's getting a little extreme. That's when you're going to have to upgrade your injectors, upgrade your fuel pump, your fuel pressure regulator, things like that, so it can accommodate that amount of oxygen content with the same amount of fuel. But you know, on here we go back to that same word again, moderate and moderation. And moderate shots, everything will compensate for it. Okay, so the nitrous does work independently from a carburetor, and it does work in conjunction with fuel injection, but it's still kind of an independent, because when you're not on the nitrous, the car's still running on its normal settings. On fuel pressures, you really want to watch with a gauge. And anytime you're checking fuel pressure, say with a regular fuel pump, say it's a muscle car and you're carbureted and you got a mechanical fuel pump, you want to check your fuel pressure with the nitrous on and full flowing, because that's when it's at its max. I mean, if you're driving around town and you say, well, I got an ideal fuel pressure for, say, a Holley type carburetor, an Edelbrock type carburetor, is between 6 and 7 psi. Okay, that's pretty normal for those kind of carburetors. You want to be right in there. Well, you might say, hey, at full throttle right now, I have 6.5 pounds per square inch of fuel pressure. Yeah, but when you activate the nitrous system, you're taking off of the fuel line, going to the solenoid, you've just opened up another port. Now it might not be able to. Kind of like your house. You're in taking a shower and you got lots of water pressure. Gardener outside turns the hose on and starts watering, all of a sudden your water pressure's gone. So all of a sudden you're like, hey man, I can't really shower, it's trickling out, because you've opened up another line. Same thing happens in a nitrous system. When you activate the system, you're tapping off of the existing fuel system, and that's another open line. So the shower head, just like in your bathroom, drops pressure, so does your fuel pump and fuel supply. So you want to check it when the nitrous is on, rather than just going down the road and going, no, I got enough fuel pressure. Easy way to do that's with a gauge, but rule number one, never mount a fuel pressure gauge inside your car without an isolator. And what an isolator does, there's several companies that make them. Autometer makes them. There's several different gauge companies that make them. All it does is take the fuel pressure and the fuel signal coming up and mounts on your firewall. You don't have the fuel coming inside the car because, boy, you don't want to have a line burst or the gauge go bad and start spraying raw fuel all over yourself. You'll end up being a barbecue, and that's not a good way to have a barbecue. So you want to be sure you use a fuel pressure isolator. And then you can monitor your fuel pressure as you're on the throttle going down the road with the nitrous on and make sure you have adequate pressure. It's worth doing that, and it's worth spending extra money to monitor this because what's at stake? Your motor. So if you lean it out and you smoke a motor, first thing it's going to do is you're like, well, there goes a couple of grand right there. It was worth spending the 75 or 80 bucks on a fuel pressure isolator and whatever it is, $30 on a gauge to save a couple of $1,000 motor. So you have to be smart about stuff like that. A lot of times people don't do this kind of stuff. They think they got good pressure, they go down the road, they hit the freeway and they got the button on and they lean out, they smoke the motor, and what do? They blame the nitrous. They go, oh, nitrous burned up my motor. We've already talked about that. That's a bunch of BS. That has nothing to do with it. That's not the nitrous's fault the motor burned up, that's the owner's fault. He should have been, he didn't set a system up right. He should have been more aware of what's going on. So obviously, because the system wasn't set up right, they blame the nitrous. Well, that's not who should be blamed. It should be the person behind the wheel that was blamed that didn't test his system. So nitrous is very safe and very street friendly if it's set up correctly. So we're talking about fuel systems here. Number one thing, like I said, don't lean out. Second thing is, obviously the higher amount of horsepower that you're setting your nitrous system up for, you're going to need more octane. And you certainly don't want to run 87 octane, the cheap stuff. You're going to want to start running a 91 octane if you're going to be on the juice a lot. Okay? Some systems, race systems, we use an entirely different tank. We have a separate fuel tank with an extreme high octane, like 114 or 120 octane fuel in it. And this is for like the dual stage systems, like fogger systems and things like that, where you're above 250, 300 horsepower and above systems. So when you activate that system, your engine normally aspirated going down the track might be on 100 octane or whatever kind of race fuel you're running on a race type engine, 100 or 108 octane, somewhere's right in there. When you activate the nitrous system, the engine is still, the carburation or fuel injection system that you're running is still running on that 100 or 108 octane. But when the nitrous system activates, what's coming through the nitrous solenoid is coming from a separate tank, also driven by a separate fuel pump, and you might have 120 octane in there to meet that because you're all of a sudden increasing cylinder pressures. Well, that's detonation. You're increasing heat. So same thing, you want to be able to, which we get into ignition systems, you want to be able to retard the timing back and you want to cool that burn down. Well, how do you do that? Just like on any race engine. Whenever you increase cylinder pressure, you need to increase the octane. You're not going to build a 12.5, 13 to 1 race motor and run 87 octane in it. Not going to happen. You're not going to have a turbo motor or a blown motor or anything like that and run 87 in it. Not going to happen. You're going to detonate. You're going to blow head gaskets, break a piston, blow a ring, do all kinds of damage. Nitrous is no different. All a turbo does or a supercharger does or just a full-on race motor with big flowing heads, camshafts with lots of overlap and high lifts, they just fill the cylinder with more fuel and air to burn. Nitrous does exactly the same thing, it's just that it's electric mechanical. You electrically activate it and mechanically fuel and an oxidizer goes in and increases cylinder pressure just the same as any other power adder does. So it's no different. So the same rules that apply to most race motors apply to nitrous motors. It's just if you lean it out, you're going to be in trouble. So you want to be sure you have adequate octane. So let's take a look at different fuel pumps and different fittings and regulators and stuff. Most muscle cars and V8s, American V8s and stuff like that, run a mechanical fuel pump. Can you run a mechanical fuel pump with nitrous? Sure, especially if it's under 150 or 200 horsepower shot, of course. The trick is though, you're going to need a good high flow pump. This one right here is by Edelbrock. It's what they call a 6-valve pump. It's a very high flowing pump. If you look at it, the inlet and outlets on it are large 3/8 pipe thread. Come on over here, same thing, 3/8 pipe, and it's as big as my thumb. Okay, that's a good amount of flow. What you don't want to have is a nice looking pump that says, oh, it's chrome or it's nice looking or whatever, and it's got little teeny fittings on it, like these guys. Okay, these are not what you want to have on a fuel pump. An adequate fuel line size is 3/8 of an inch. This barb right here is 3/8 of an inch. You got to be careful of these fittings though, because come down here, these obviously are different size, but just for comparison I want to show you. If we look at this fitting right here, it's got a hole all the way through it, and it's a good size hole, 3/8 of an inch. Okay, if we look at this fitting right here, looks like it's 1/4 inch, and the hole looks pretty big on this side. Watch what happens over here though. Come over here, there's a little micro hole on this side. This is what you got to watch out for in brass fittings. Can you imagine having a fitting like this on a fuel pump and you think, hey, I got a particular size fuel line on here. Well, the pump's trying to flow. Everything else, the line from your tank all the way up to the pump might be big. The line going from the pump to your carburetor might be big. But then you get this little teeny restriction in there like that. I mean, that's a little micro hole. This is for like an air pressure line or something like that. So you got to be careful this kind of stuff and make sure that even though you have a particular size brass fitting, make sure the hole in it is a correct size, because sometimes they do step down. That'll cause a massive decrease in fuel flow. You go hitting that nitrous with a fitting like this on here, you're going to lean out, you're going to pop that motor, you're going to melt it down. So be sure when you're running fittings that they are straight through and that the hole inside is adequate. So high flow pumps, same thing with electric pumps, exactly the same thing. This is a good aeromotive pump. These things flow a lot, way more than any stock factory pump could ever flow. So if you're running an EFI system and you need 60 or 70 pounds of fuel pressure somewhere in there, or more or less, you need a pump like this. So a lot of times when you're running lots of juice, or lots of nitrous, you're going to want to upgrade the fuel system. The more power you're going to run, obviously you're going to have to upgrade the fuel system more. But if you keep it, again, moderation, a stock pump would be just fine if you use it in moderation. If your pump's not adequate and you've checked your fuel pressure and it's not adequate, just upgrade to the next pump. You can call nitrous places, nitrous supply, nitrous oxide systems, any of the good nitrous companies like that, Edelbrock, they all have good tech lines. And whatever system you purchase, give them a call and say, hey, I need a little help. I have this, my fuel pressure does this. They're tech lines, this is what these guys do for a living. They'll be glad to help you on that kind of stuff, and they'll point you in the right direction and suggest a pump that you should use. Of course, if you have too much, which is common, if you have too much fuel pressure and fuel flow, you're going to need a good regulator. And this is another aeromotive one. This is for a big boy motor, 500 plus, 600 cubic inches. This thing flows, it returns a lot of fuel and it can regulate a lot of fuel. Most pumps put out more than you can possibly use, especially in EFI systems or even mechanical fuel injection. They return it back to the tank. Where a smaller system, the fuel pressure regulators, they just adjust the pressure and there is no return line. But depending on which system you want to use and how hardcore you're going, I mean, if you're going to run a 400 horse shot or a 500 horse shot, you're certainly not going to use a 70 gallon an hour fuel pump and a little teeny regulator. You're going to need some big old lines and a massive pump and a big regulator to be sure that when you're on that juice, you got adequate fuel flow. You don't want to lean that motor out. Another very important thing in a fuel system are filters. This is also by Aeromotive. This is a 100 micron filter, really, really good. If you notice, it's super high flow. Look at the inlet size and the outlet size. They're massive. You need adequate flow. Fuel filters are very, very important, especially in a nitrous system. If you go clogging up a nitrous line or a jet line or anything like that, especially on the fuel side, you're done, okay? The motor would be toast. And it'd be stupid for a cheap little filter to wipe your motor out. I mean, obviously a filter like this, this guy right here is not so cheap, but that's cheap life insurance, okay? But obviously you can get a less expensive filter. You don't need anything like that for a moderate shot of nitrous. But a lot of nitrous systems come with fittings with little teeny screens, and if you look right there, there's a little tiny screen. These go right onto the solenoids. It just ensures that stuff can't get into the solenoid and mess it up. But it's a filter. You got to check this stuff every now and then, because you might say, well, I got a new tank, or maybe your car's pretty new or something like that. You can still get dirt in there. Even when you fill up at the gas station, they have filters. I've seen filter material clog this up. I had a motor one time. It was a nitrous motor, and you'd get on a nitrous and it would surge, do its little weird thing. You're like, what the heck? We found filter material in here. It was actually when they put the fuel filter together, some of the paper element inside must have got crimped, and actually a piece of the filter itself got lodged downstream of the filter itself. So just check these little things, because they're there for a safety reason. You can't just put it on and forget about it. These types of motors and these types of little things do need a little bit of maintenance. We're going to talk about jetting now and how to properly jet your nitrous system or your vehicle and what to look for, and basically by reading spark plugs. Spark plugs can tell a whole story of what's going on with the motor, whether it's running too rich, too lean, too hot, too cold. First off, we're just going to go over spark plugs and some things about them. First and foremost, let me start off by saying this. There are heat ranges. Every spark plug has a given heat range. And there's a real misconception out there. People say, oh, I don't want to run too hot of a plug because it'll overheat my motor. That's the biggest line of crap I've ever heard in my life. The spark plug, I can hold a spark plug in my hand. It's not hot. It's not heating my motor up. The motor heats the spark plug up, not the other way around, okay? So basically, heat ranges, all it means is what the temperature of the plug itself is going to be running at. All right, now let's consider this. Let's say the plug has a very cold heat range. That means it's not going to absorb any of the combustion heat, all right? And you say, well, that's perfect. Why wouldn't you run something like that? Problem with that is a cold spark plug, just like try and do dishes in your dishwasher and try and do it with cold water. Not going to happen. You're not going to get the grease off. Well, what's inside the motor? Oil, gasoline, they're all solvent, grease-based, oil-based products. Okay, so heat is what you need. The hot water clean your dishes and hot water cleans the grease off. Same thing happens inside the motor. If you've got a cold spark plug, little particles of oil and gas deposits will stick to it and it won't burn off. So the opposite of that, you might say, well, Aaron, why don't we just run a super hot spark plug? Problem with a super hot spark plug is the plug temperature itself can't maintain or can't handle that kind of temperature, and you melt the electrodes off. And I'll show you that as we go through these different plugs. But the heat range of a spark plug certainly has nothing to do with how hot the motor is going to run. You can put a stone cold plug in your motor, and if it wants to run at 195 degrees, it's going to run at 195 degrees. If you want to put an ultra hot plug in there and it wants to run at 195, it's still going to run at 195. It has nothing to do with the cylinder temperature. The fuel mixture inside the cylinder temperature is what dictates how hot that's going to burn. Okay, the spark plug has nothing to do with that. The key is you want to run the hottest spark plug you can possibly run without having it melt down and without having it run cherry red or anything like that, without melting electrodes off. That way deposits don't stick to it. It keeps itself clean. It's basically like a self-cleaning oven. You ever see a self-cleaning oven? You turn it on. What does it do? The thing goes up to like 800 or 900 degrees and sits there for 2 or 3 hours. It just bakes everything off the inside. It turns it into an ash and it falls off. That's what happens to a spark plug. All the stuff that sticks to it turns to an ash and out it goes. From the velocities of when the intake valve opens, the incoming cool air fuel charge coming in, it kind of cleans that up. In fact, with nitrous systems, there's a little joke in the industry we talk about, giving yourself an instant tune-up. You want to give yourself an instant tune-up, just go down the road and hit the nitrous for a second. Just go, and hit the nitrous. That'll clean the spark plugs right off. Why? Because at instant cylinder heat, you just added more fuel in there. You're burning it faster with more oxygen content. It heats these babies up and just burns everything right off them. Instant clean plugs. So it's kind of an industry little joke that we talk about, that nitrous will give you an instant tune-up. So we're going to talk about the different types of spark plugs and what you should run and what you shouldn't run. And we'll start with this one right here. This is what they call an extended electrode spark plug. And what that means is, if we're looking at it, the electrode up here protrudes out away from the base of the plug. This is the ground strap. The outer part right here is the ground strap. The inside is actually the positive electrode. That's where the juice is coming from the coil. That's where electricity comes in. And let me say this too. Don't fall for gimmicks, okay? A spark plug is a spark plug is a spark plug. All right, there's all kinds of expensive gimmick plugs out there with split tips or all these fancy little corrugated electrodes and stuff like that. A spark plug provides a gap, an air gap for electricity to jump across. So don't be buying $9 or $10 spark plugs when a $1.29 plug will do you just the same job, okay? There's a lot of advertisement out there it just doesn't work. All right, so also with that, let me kind of give you an idea on the electrodes, that what you're looking for and what you're not looking for. Extended tip electrodes you don't want with forced induction or nitrous oxide or anything like that. Why? Because this electrode right here is protruding out into the heat in the cylinder. Well, it's a very thin little strap. I mean, if you look at the strap right here, this little ground strap right here is very thin, and it's sitting out into the cylinder. Problem with that is it's picking up the heat. So imagine this. Imagine if I had a paper clip and I held a match underneath the paper clip. Well, in about 5 seconds, I can make that paper clip glow cherry red, all right, because it doesn't take much heat to make it glow cherry red. Imagine if I turn that paper clip into, a Phillips screwdriver, something that's, a 1/4 inch thick. I can hold a match on it all day and it's not going to glow cherry red, that's for sure. It's going to take a hell of a lot more heat to get that thing to glow cherry red because it's a larger mass of metal. You go stick in a split tip spark plug in your combustion chamber, what's going to happen is when you take that same mass, that mass of the electrode, the ground strap electrode, and you split it in half, you've just basically cut that mass down by 50%. So each little side of that split tip is going to glow cherry red. Now you got a diesel motor, you got a glow plug in there that can't cool down fast enough. It won't even wait for the spark to jump across the gap to fire the cylinder. As soon as it fires and those electrodes, the little pieces of electrode get hot and they start glowing cherry red, you get pre-ignition or detonation. It's going to fire it whenever it wants to, and I'll tell you what, that's catastrophe. You'll lose the motor, especially if you're on the nitrous at that time. It's gone. Kiss it goodbye. So it's very, very important that you control the spark and the spark timing. And that can be controlled by also the coolness or the heat of the spark plug and the size of the ground strap. But extended tip electrodes you don't want to use. What you want to use is a standard electrode, which is like this. And if we look, it's a lot less in there. In fact, I'll get the other plug back here and you can compare the two. you can plainly see that this electrode right here, it's a lot smaller and shorter. It's not sticking out into the combustion chamber as far as this one does. So it's less mass out there, less apt to heat up and glow cherry red. So you don't want to use these extended tip electrodes in a nitrous motor. Just kind of stay away from those. There are other plugs available that don't have the extended tips. Now, a little thing with this also, on heat ranges, anytime you run nitrous and you're going to increase the heat for a given cylinder or a given combustion, you're going to want to go a little step or two down in spark plug heat range. So let's say you're using a plug right now in the middle of the heat range area. You want to go a one step or two steps down, a little bit colder when you're running on the nitrous. And that just ensures that when you're on the juice and the nitrous going in or cylinder temperatures come up, that the spark plug can maintain an adequate heat without melting down. Okay, so sometimes you might want to do that. You can run them with your factory plugs if it's a small shot. So if it's, you know, a 50 horsepower on a V8 engine or 60 horsepower, you can probably get away with your stock plugs. But if you're going to run 100 horse or 200 or something like that, you want to start stepping down the heat range on the spark plugs. So let's go to the next one here. Just in case you get stuck having to run extended tip electrodes, there is a little trick you can do. And this also works for non-extended tip also, but we can file this ground strap down a little bit. If we look right here, you see the ground strap on here, it's been cut down. If we compare it to a regular one, you can see how far this ground strap right here protrudes. Okay, well we don't want that. We've actually cut it back a little bit. Well, that cuts the mass down. This is a shorter strap right here, so what's going to happen is it's going to take more heat or a longer duration of heat to get this smaller mass, the shorter mass, to glow cherry red as it would the longer mass, because it's, you know, this is gathering up more heat than this will. So there's a trick you can do. You can file these down a little bit to about halfway across the center electrode right there. If you look at that, it's about halfway across. That's a little trick that can help you. It's not the ideal. You should still go with a non-protruded tip or non-extended tip plug. But if you're stuck and that's all you can do is get those, then go ahead and file them back like that, and that'll help you a little bit. So let's go on down and look at jetting also here. If you're running too rich or your spark plugs are too cold, here's the first thing that's going to happen. It's going to turn black and sooty. This is very typical of running rich. That's gasoline deposits stuck on there. A way to remedy this would be, it's either telling you that you've got too much fuel going in there or that the heat range of the plug is too cold. Assuming that you didn't go down too far on the heat range, let's assume that the heat range is adequate, that you didn't go down 5 steps to the coldest plug you could possibly get, okay? Let's just assume that first off. If you didn't do that, then this is telling you there's too much fuel in the system, okay? You need to lean it out a little bit. Again, don't just start leaning things out. You only want to go down 1 step or 2 steps on the fuel side. Don't go all of a sudden 5 steps or something. That's not a good thing to do. Again, worst comes to worst, call the tech line. If you got a NOS nitrous system, call NOS. You can call Nitrous Supply. They all have good tech guys. They'll help you through this. But this is definitely too rich. Okay, that's not good. You're not getting a good clean burn. If we go to this one, here's what happens when you're too lean. This one, when it's too lean, look what happened to the electrode. You can see it's completely melted back. This is what happens when there's too much heat in there. This was an extended tip electrode in a nitrous motor, and guess what happened? It couldn't take the heat and it melted down. So we have to kind of watch that. So that's telling us, oh boy, we're either too lean or the spark plug temperature was too hot. So you kind of have to assume things first. What I would recommend first and foremost, rather than spark plug temperature, I would make sure you're on the rich side. So I would go up on jetting on this first. Don't mess around with nitrous. You don't mess around with a lean nitrous motor. So before you go saying, well, let's just put a colder plug in it, step up the fuel side of the nitrous system 1 more jet size or 2 more jet sizes and see if that makes it go away. If it doesn't, then go down to a little colder plug. But always assume that you're on a lean side rather than just the heat of the plug with nitrous. You don't want to play around with a lean motor. That's just, you're asking for trouble on nitrous. But this is what happens. It just completely melts it down. That's not happening, because if the spark plug's doing this, guess what's happening to the top of your piston? It's aluminum. Okay, same thing. You're going to stipple it, you're going to start melting it, and little pieces like this that melt off are going to get between your piston and the cylinder wall, and they're going to do damage to it. Okay, so you got to be careful with that. Let's look at this little guy. This is a nice, clean burning plug. You can see it's a nice brown inside, and it's got no deposit stuck to it. It's just a nice run plug. This is what it should look like, just a nice tan to a little brownish tan color down inside the electrode here. And that's a really nice looking color there. And you can see the top of the porcelain inside, everything's looking good. That's what you're trying to achieve. And if you can get your plugs to look like this, you're doing real good. All right, let's look at the last plug here. This is from Zex Systems, Zex Nitrous Systems. This is a new plug design right here. It's got 3 electrodes, and remember I just said don't fall for gimmicks. This isn't really a gimmick plug. It's not going to fire like a shotgun. It's not going to get 3 different sparks. That's all just horse hockey, okay? You only get 1 shot from the coil. Pow, it fires. If you got a multi-spark discharge, it goes pow, 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 pow a couple of times, but it doesn't change locations. Electricity takes the path of least resistance, okay? Heat can cause resistance. So you might get one to fire a couple of times here, then one over here, or it might fire for a little while here, and then as you're driving down the road, it might switch times over here because this electrode or ground strap got a little warm and it increased resistance, so it'll change to over here. But they don't fire all at once. The cool thing with a spark plug, what it's designed for, look how short the ground straps are. They're little teeny shorties, and we just talked about that. You could file back the ground straps on some of the plugs. Well, these are little short guys, so they're less apt to get heated by the combustion temperature and glow cherry red. So this is less apt to cause detonation in a motor. Well, that's why these are designed for nitrous motors, because of the short ground straps. So you always want to kind of check that on spark plugs and test your jetting, test your heat range of the spark plug, and just read the spark plug, and it'll tell a whole story. So once you understand what the story looks like, which I just showed you here, you can adjust the car accordingly.